Hello friends, welcome to Student Academy. In the last lecture we have discussed in detail about the line integrals. So in this particular lecture we will start our discussion on the top 30 questions of the line integral. So let's start our discussion on the questions. Let's begin. Let us discuss question number 1, what we have to solve. Let us solve this. So we have to evaluate the line integral, that is f dot dr, along the curve that is given as the arc of a parabola. So we have the parabola as y is equal to x square in the xy plane, and we have to find evaluate the integral from 0 comma 0 to 1 comma 1. Okay, so along this particular curve we have to find the line integral. Okay, so let us take this as I. So we have the value of f as x square I cap plus y cube j cap, and we have to take this as dot product f dot dr. So let us take the position vector as x I cap plus y j cap. So we have the dr vector as dx I cap plus dy j cap. So this is dx I cap plus dy j cap. So this will be equal to, and this is along the curve C. So the curve C is this one, from 0 0 to point 1 comma 1. Okay, so this is point 1 comma 1 and this is our origin. So along this curve we have to evaluate the line integral. Okay, so let us further simplify this. So we have the value of I as, so let us take the dot product. So this is x square and this is dx. So x square dx plus this is y cube and this is dy. So this is y cube dy. Okay, so यहाँ पे क्या है, सारा टर्म्स क्या है, x के टर्म्स में है, this is in terms of y. So let us place the limits. So x limit is from 0 to 1. So x limit is from 0 to 1 and y limit is from 0 to 1. So let us place the limits. So x limit is from 0 to 1 and this is from 0 to 1. Okay, so value of I is, let us integrate this. This is x cube by 3, limit is from 0 to 1, plus this is y4 upon 4, limit is from 0 to 1. So this will be equal to 1 upon 3 plus 1 upon 4. So this is 7 upon 12. So 7 upon 12 is the value of the line integral along the curve C given by the arc of a parabola. This is equal to 7 upon 12, and this is our curve C, that is arc of a parabola from 0 comma 0 to 1 comma 1. So let us discuss question number 2, how we can solve this. So similarly we have to evaluate the line integral. So let us take this as I is equal to f dot dr line integral. The curve C is arc of a curve. Okay, so this is y is equal to x cube. Okay, so this is the graph of a y is equal to x cube. Okay, so we have to take this from 0 comma 0 to 2 comma 8. The 2 comma 8 will be somewhere here. So this is 2 comma 8. So along this curve, we have to evaluate the line integral. Okay, so let us solve this. So we have I as f dot dr along the curve C. So this is equal to x square minus y square I cap plus xy j cap into dr. So dr we can write as dx I cap plus dy j cap. So this will be equal to x square minus y square into dx plus xy into dy, and we have the value of y as x cube. Okay, so let us place the value of y. Okay, so let us convert everything in terms of x. So we have, this is x square minus the value of y square will be, this is x cube ka whole square, this is x to the power 6 into dx plus, let us place the value of y. So the x times of y as x cube into, so we have y is equal to x cube, then dy will be 3x square dx. So this is 3x square dx. Okay, so we have the limit from, so x varies from 0 to 2, x varies from 0 to 2, 0 to 2. So this is equal to x cube by 3 minus x 7 by 7. Okay, so this is 2 and 0 plus this is 3 times of, this is um, 3 times of this is 3 times of 5x6 dx. So this will be 3 times of x7 upon 7. The limit is 2 and 0. So this will be equal to, this will be, let us further simplify this. So we have the value of I as 2 to the power cube upon 3 minus 2 to the power 7 upon 7 plus 3 into 2 to the power 7 upon 7. So this will be equal to 8 upon 3, and this will be 2 times of 2 to the power 7 upon 7. So this will be equal to 8 upon 3 plus 2 to the power 8 upon 7. Okay, so let us further evaluate this. So let us use the scientific calculator for solving this. So this will be equal to, so this is equal to 824 upon 21. So this is equal to 824 upon 21, the value of is. Okay. So this calculator is allowed in the exam, so you can use this for ease of simplification and ease of calculation. So let us solve question number 3. How we can solve this? So we have the value of f as f is equal to 3xy I cap minus y square j cap. We have to evaluate f dot dr, that is the line integral, and c is the curve in xy plane, that is y is equal to 2x square. From the limit is from, so we have the curve as y is equal to 2x square, and the limit is from 0 comma 0 to 1 comma 2. So this is 1 comma 0, 1 comma 2 is the limit. Okay, so this value will be 2, 0 comma 2. So x varies from 0 to 1 and y varies from 0 to 2. Okay, so this is 3xy I cap minus y square j cap. So let us use the this we can solve in two ways. Okay, so we can directly put y is equal to 2x square, or we can convert this into parametric form. Okay, so let us use the method 1, that is directly we can find f dot dr. So f dot dr will be along the curve c is equal to 3xy I cap minus y square j cap into dr. So dr we can write as dx I cap plus dy j cap. So we have this as 3xy into dx minus y square dy. Okay, so this will be along the curve c. So this is equal to, so we have the value of y as 2x square. So let us place the value of y as 2x square. So this is 3x times of 2x square dx minus y square dy. So limit of y is from 0 to 2 and limit of x is from 0 to 1. 0 to 1. So this is the value of integral. So I is equal to 3 to the 6. 6 times of this is x square and this is x. So this is x cube dx. X cube dx, this will be x4 upon 4. Limit is from 0 to 1 minus this will be y cube upon 3. Limit is from 0 to 2. So this will be equal to 6 upon 4 minus this will be 2 ka cube 8 upon 3. So this will be 3 upon 2 minus 8 upon 3. This will be equal to 9 minus 16. So this will be equal to minus 7 upon 6. So the value of integral will be minus 7 upon 6. Value of I will be, so we have value of I as f dot dr along the curve c. So this is equal to minus 7 upon 6. Okay, so now let us discuss question number 4, how we can solve this. Find the work done when a force moves in a moves a particle in xy plane from 0 comma 0 to 1 comma 1 along a parabola y is equal to y square is equal to x. Okay, how we can solve this? So we have already studied that the work done by a force from moving a particle from one position to another is given by f dot dr, f dot dr, okay, along the curve that is given by c. Okay, this is the value of work done. Okay, so from point 0 comma 0 to 1 comma 1, so y square is equal to x is like this, y square is equal to x, so this is 0 comma 0 and this value is 1 comma 1. Okay, so in moving the particle from this position to this position, the work done is given by this particular expression. The limit will be from 0 comma 0 to 1 comma 1. Let us find this. The work done is equal to x square minus y square is plus x I cap minus 2xy plus y. This is f dot dr. Dr will be dx I cap plus dy j cap. So this is equal to x square minus y square plus x into dx minus 2xy plus y into dy. So we have x square minus y square is equal to x. So this is equal to x plus x into dx minus this is 2x plus 1 into y dy. So this will be equal to, this gets cancelled, this is x square dx minus, and we have the value of x as y square, this is 2y square plus 1 into y dy. Okay, so we have the value of the limits as, so x varies from 0 to 1 and y varies from 0 to 1. Okay, so this is the value of integral. So let us further simplify this. So I is equal to, this is 1 upon 3 minus this will be 2y cube, this is y cube dy, this is y4 upon 4, this is 1 comma 0 minus this is y square upon 2, 1 comma 0. So this is I is equal to 1 by 3 minus 2 upon 4 minus 1 upon 2. So this gets cancelled. So this is equal to 1 upon 3 minus 1 upon 2 minus 1 upon 2. So this is 1 upon 3 minus 1. This is minus 2 upon 3. Okay. So the value of I is minus 2 upon 3. Okay. So the work done by a force in by moving a particle from 0 comma 0 to 1 comma 1 is given by minus 2 by 3. Okay. So let us discuss question number 5. How we can solve this? So we have to evaluate x dy minus y dx. Okay, around a circle given by x square plus y square is equal to 1. So let us convert this into a parametric form. Okay, so we can take, in terms of parametric form, we can take x as, because the radius is 1, x as cos t and y as sin t. Okay, so let us take this as I. So I is equal to, let us place the value of, so from here x is equal to cos t, so we have dx is equal to minus sin t dt, and from here we have dy as cos t dt. Okay, so we have this as value of x as cos t into dy, will be cos t dt, cos t dt, and from here we have the value of y as sin t into dx is minus sin t dt. Okay, so this is equal to cos square t dt plus sin square t dt. Okay, so this is a circle. Okay, so the t will varies from, this is theta, t is equal to 0 here. Okay, so t varies from 0 to 2 pi, t is the angle, so t varies from 0 to 2 pi because this is a circle. Okay, so in traversing the complete circle considered as t, so t varies from 0 to 2 pi. So angle will be from 0 to 2 pi. So this is equal to, I is equal to cos square t plus sin square t into dt, and the t varies from 0 to 2 pi. So cos square t plus sin square t is 1, so this will be equal to 2 pi. So the value of x dy minus y dx is equal to 2 pi. Now let us discuss question number 6, how we can solve this. So we have to find f dot dr, that is line integral along the curve given by y is equal to under root of 1 minus x square in the plane from 1 comma 0 to 0 comma 1. How we can solve this? So we have this curve as y square is equal to 1 minus x square. So from here we have x square plus y square is equal to 1. So this curve will be like this, 1 comma 0. So 1 comma 0 is somewhere here, 1 comma 0 and 0 comma 1. This is 0 comma 1. So our curve C is this one. This is our curve C. Okay, so we have the integral as I is equal to cos y I cap minus x sin y j cap dot dx I cap plus dy j cap. So this is equal to cos y into dx minus x sin y into dy. Okay, I integral along the curve C. So this we can write as differentiation of x cos y. Okay, so if we differentiate this x cos y, so this will be equal to x differentiation of cos y will be minus sin y dy plus cos y into dx. So this is similar to this expression, cos y dx minus x sin y dy. Okay, so and integration is from, the coordinate is from 1 comma 0 to 0 comma 1. So let us place the value. So the integral of this will be x cos y, and let us place the limit. So this will be from 1 comma 0 to 0 comma 1. So let us place 0 comma 1 first. So x is equal to 0, so this whole term will be 0, and we have secondly we have 1 comma 0. So the value of x is 1 and cos of 0 is 1, so this will be minus 1. So value of integral is minus 1. So value of this f dot dr along the curve C is minus 1. So let us discuss question number 7. Evaluate f dot dr where f is given by xy I cap plus x square plus y square j cap, and the curve C is the arc of y is equal to x square minus 4. How we can solve this? So we have the integral I as f dot dr along the curve C. So this is equal to xy I cap plus x square plus y square into j cap dot product with dr. So this is dx I cap plus dy j cap. So this will be equal to xy into dx plus x square plus y square into dy. Okay, let us further simplify this. So we have the value of y as x square minus 4. This will be x square minus 4 into dx plus, and we have this as x square will be y plus 4. So this we can place the value of x square as y plus 4 plus y square into dy. Okay, and we have the limit on x is, x varies from 2 to 4. So this is x is equal to 2 to x is equal to 4, and y limit is 0 to 12. Okay, so I is equal to, this is x cube minus 4x into dx, 2 to 4 plus this is y square plus y plus 4 into dy. This is 0 to 12. So let us further simplify this. So value of I is, this is x4 upon 4 minus 4 x square upon 2. So limit is from 4 comma 2 to 4 and limit is from 2 to 4. Okay, plus this is y cube upon 3 plus y square upon 2 plus 4y. Limit is from 12 and 0. So I is equal to 4 to the power 4 upon 4 minus 2 to the power 4 upon 4 minus this is 2 times of this gets cancelled to 2. So 2 times of 4 to the power square minus 2 to the power 4 square minus 2 to the power 2. Okay, plus 12 cube upon 3 plus 12 square upon 2 plus 4 into 12. So I will be, let us use the scientific calculator. This is equal to 732. Okay, now let us discuss question number 8. How we can solve this? Evaluate I is equal to xy cube ds, where c is the segment of a line y is equal to 2x in the xy plane from minus 1 comma minus 2. So this is minus 1 comma minus 2 to 1 comma 2. This is 1 comma 2. So along this line we have to evaluate the line integral. Okay, so how we can solve this? So we can write this as, let us take convert this in the parametric form. Okay, so we have, let us take we have the equation of the line as y is equal to 2x. So let x is equal to t, then y is equal to 2t, and t varies from, because x varies from minus 1 to 1, so t varies from minus 1 to 1. Okay, so since x varies from minus 1 to 1, so t will also vary from minus 1 to 1. So let us evaluate this. So we can write I as xy cube into ds upon dt into dt. Okay, so let us convert everything in terms of t. Okay, so let us first find ds upon dt. How we can find this? So we have dr upon dt. We can write this as dr upon ds into ds upon dt. So let us take mod both side. So we have dr upon dt as dr upon ds commod into ds upon dt commod, and ds upon dt is scalar quantity because s is the arc length. Okay, suppose we take a curve, then s is a arc length. So this is not a vector quantity, this is a scalar quantity s. So ds upon dt is always a scalar quantity, and dr upon ds is a unit vector. Okay, so whenever we draw a tangent on a curve, so the unit vector along this tangent is given by dr upon ds. So the modulus, so mod of this will be 1 because mod of unit vector is always 1. So now we have, let us take r as r is equal to x I cap plus y j cap. Okay, so we have in terms of t, we have the value of x as t and y as 2t. So r vector is equal to t I cap plus 2t j cap. So we have dr upon dt as I cap plus 2 j cap. So from here dr upon dt mod is equal to 1 plus 4 under root. This is root under 5. So this will be root under 5 is equal to dr upon ds commod is 1 into ds upon dt is always a scalar quantity. So no need to place mod here. So the ds upon dt is root under 5. ds upon dt is equal to root under 5. So let us place the value of everything and place the limit of t from minus 1 to 1. So let us place ds upon dt as root under 5. So I is equal to value of x is t into value of y is 2t, so 2t ka whole cube into ds upon dt is root under 5. So now let us place the limit as minus 1 to 1. So this is equal to 2 times 2 ka power 3. So this is equal to 8 root under 5 into this is t times of t into t cube. So this is t4 dt and limit is from minus 1 to 1. So this is equal to 8 root under 5 into t5 upon 5. Limit is minus 1 to 1. Okay, so this will be equal to 2 times of 8 root under 5 into 1 upon 5. Okay, so this is 16 upon root under 5. This is equal to 16 upon root under 5 is the value of this, 16 upon root under 5. Okay, as simple as that. Let us discuss question number 9. How we can solve this? So let us evaluate this. So we have I as f dot dr along the curve C. So C is, and the curve C is r is equal to t I cap plus t square j cap plus t cube k cap, and varying from minus 1 to 1. So t vary from minus 1 to 1. So let us convert everything in terms of t. Okay, so we can write the integral as f dot dr upon dt into dt, and the limit on t will be minus 1 to 1. Let us convert everything in terms of t. So we have the position vector as this particular expression. So we can, in terms of Cartesian form, we have the value of r as x I cap plus y j cap plus z k cap. So on comparing both the expressions, this and this, we have x is equal to t, y is equal to t square, and z is equal to t cube. Okay, so we have the value of f as, f is given as xy I cap plus yz j cap plus zx k cap. So from here we have f is equal to xy. So xy will be t to the power 3, t to the power 3 I cap plus yz, yz. So this is t to the power 5 j cap plus zx. This is z and this is x. So this is t to the power 4 k cap. Okay, and we have dr upon dt as, so we have dr upon dt. From here we can find dr upon dt. So dr upon dt is I cap plus 2t j cap plus 3t square k cap. Okay, so we have f dot dr upon dt. So I is equal to f dot dr upon dt. So this is t cube I cap plus t to the power 5 j cap plus t to the power 4 k cap dot product with dr upon dt. This is I cap plus 2t j cap plus 3t square k cap. Okay, so this is along the curve C. Let us further simplify this. So we have the value of I as t cube plus 2t6 plus 3 times of t to the power 6. Okay, this is dt. Sorry, f dot dr into dt, you know, f dot dr. We have the I as f dot dr upon dt into dt. Okay, so we have calculated f and we have calculated dr upon dt, and we are taking the dot product. So this is the dot product into dt. So this is dt, and the limit on t is minus 1 to 1. So let us further simplify this. So we have I is equal to, so this is t4 upon 4, limit from minus 1 to 1, plus this is 5 times of t7 upon 7, limit is from minus 1 to 1. Okay, so this will be 0 as this is a even function. So I is equal to 2 times of 5 upon 7. Okay, so this is 10 upon 7 is the answer. Let us discuss question number 10. How we can solve question number 10. So we have the value of f as 2x plus y I cap plus 3y minus x j cap. Okay, so we have to find the line integral where C is the curve in xy plane consisting of a straight line from 0 comma 0 to 2 comma 0. So this is 0 comma 0 to 2 comma 0. This is lying on a straight line 2 comma 0. And after that we have to move it to 3 comma 2. This is 3 comma 2. Okay, so along this curve we have to find the, along this line we have to find the line integral. Okay, so let us name this. This is OA and this is A, this is B. Okay, so OA and AB. Okay, so we can break this in OA and AB curve C in this is OA f dot dr plus this is AB f dot dr. Okay, let us find this. So we have the integral along OA. So along OA we have the value of y as 0 and dy is also 0. Okay, and let us find the equation of AB. How we can find this? So we have the equation as y minus y1. How we can find the equation of a straight line from point x1 y1 to x2 y2? So this is y minus y1 is equal to y2 minus y2 minus y1 upon x2 minus x1 into x minus x1. So we have the equation as 2 comma, sorry, the coordinate as 2 comma 0 to 3 comma 2. So we have y minus 0 is equal to 2 minus 0 upon 3 minus 2 into x minus 2. So this is y is equal to 2 times of x minus 2. So from here y is equal to 2x minus 4. So the equation of a straight line is y is equal to 2x minus 4. Now let us further simplify this. So let us find the integral along OA first. So we have integral along OA f dot dr is equal to, so this is directly we can write this. So we have dr as dx I cap plus dy j cap. Okay, so let us take dot product of this and this. So we have 2x plus y into dx plus 3y minus x into dy. Okay, and value of this is along OA. So we have along OA y is equal to 0. So this y will be 0 and here dy will also be 0. So this particular term gets vanished. So we have only 2x dx. So 2x dx and integration x varies from 0 to 2. So this is 2 into x square upon 2. This is 0 to 2. So this is 2 square is equal to 4. So value of f dot dr along OA is 4. Okay, now let us find f dot dr along AB. So this is f dot dr along OA is 4. Now let us find this. So along AB f dot dr is equal to, along AB this is 2x plus y dot product. Let us take dot product, that is f dot dr. So this is dx I cap and there we have dx. So plus 3y minus x into dy. Okay, so this will be equal to 2x plus y, 2x plus y. So we have value of y as 2x minus 4. Value of y as 2x minus 4. So we have 2x plus, place the value of y as 2x minus 4 into dx plus, and we have the value of 3 times of, we can place the value of x in terms of y for ease of simplification. This is 3y minus the value of x is y plus 4 upon 2 into dy. Value of x will be, from here x is equal to y plus 4 upon 2. Okay, so let us further simplify this. So this is 4x minus 4 into dx plus this is 3y minus y upon 2 minus 2 dy. Okay, So integration is from, the x limit is from 2 to 3, x is equal to 2 along AB, x varies from 2 to 3, x is equal to 3, and here in y varies from 0 to 2, 0 to 2. Let us further simplify this. This is value of I. So I is equal to 4 times of this is x dx. This is x square by 2 minus x. Limit is 3 and limit is from x is equal to 2 to 3. 2 to 3. Okay. Plus this is 3y square upon 2 minus this is half into y square upon 2 minus 2y. Limit is from 0 to 2. Okay. Let us further simplify this. So I is equal to 4 times of 3 square by 2 minus 3 minus 2 square by 2 minus 2 plus this is 3 into 2 square upon 2 minus 2 square upon 4 minus 2 into 2. Okay, so this is equal to, this gets cancelled. So 4 times of 9 upon 2 minus 3 minus this is 2 minus 2, this gets cancelled. Okay, plus this gets also cancelled. This is 6 minus 1 minus 4. Okay, let us further simplify this. 6 minus 5 is 1. 4 times of 9 minus 6 upon 3, sorry 2 plus 1. So this gets cancelled to 2. This is 9 minus 6 is 3. 2 times of 3 plus 1. 6 plus 1 is 7. Okay, so the complete solution will be, complete solution of along the curve C, f dot dr will be equal to along OA f dot dr plus along AB f dot dr. Okay, so we have the straight line as along OA, that is O to A and then from A to B. Okay, so the coordinate of O is origin and A is 2 comma 0. This is 2 comma 0 and then to 3 comma 2. So this is the integral along AB and this is the integral along OA. So the value along OA f dot dr is equal to 4 and along AB f dot dr is equal to 7. So this will be equal to 4 plus 7. So the value of line integral is equal to 11. Answer. ठीक है. So let us discuss question number 11. How we can solve this? So we have to evaluate f dot dr along the curve C, and C is given as a rectangle in xy plane bounded by, so we have this as xy plane as this is x and this is y. So we have a rectangle bounded by y is equal to 0. Okay, so this is y is equal to 0 and x is equal to a, so this is x is equal to a, and we have y is equal to b, so this is y is equal to b, and this is x is equal to 0, x is equal to 0. So this is our rectangle. Okay, this is our rectangle. So let us name this. This is O, this is A, this is B, and this is C. So along OA we have y is equal to 0, y is equal to 0, and dy is equal to 0. And along CO we have x is equal to 0 and dx is equal to 0. And y varies from y is equal to b to y is equal to 0. And along BC we have y is equal to b and dy is equal to 0. There is no change in the value of y is constant. And along AB we have x is equal to, along AB we have x equal to a and dx is equal to 0, and y varies from y is equal to 0 to y is equal to b. So this we can break as, so curve C, we can break curve C into OA, AB, BC and CO. So we have the value of integral as OA f dot dr plus AB f dot dr plus BC f dot dr plus CO f dot dr. So let us find one by one. So OA f dot dr is equal to, the value of f is x square plus y square, f dot dr directly we can write, into dx minus 2xy into dy. Okay, so along OA we have y is equal to 0, so this gets vanished, y square, and we have dy is equal to 0, so this expression gets vanished. So we have x square dx. Okay, x square dx, and x varies from 0 to a, so this is a cube upon 3. Okay, so y square is 0 because y is 0 here, and dy is equal to 0, so this whole term 2xy dy will get vanished. So we have this as OA f dot dr. So value of OA f dot dr is equal to a cube upon 3. Okay, so now we have now let us find f dot dr along AB. So along AB we have dx is equal to 0, so this whole term gets cancelled. Now we are having dy. So dy, y varies from y is equal to 0 to y is equal to b, and x is a here. So we have minus 2 into a into y square upon 2, and this is y limit 0 to b. So this is minus 2a into 1 by 2 into b square. So this is, sorry, this gets cancelled, this is minus ab square. So we have the integral AB f dot dr is equal to minus AB square. Now let us find along BC. Along BC we have y is equal to b, dy is equal to 0. So dy is equal to 0. So this whole expression gets vanished. So now we have x square plus y square dx. Okay. So we have x square plus, and y is b, the b square into dx. And limit on x is equal to a, x is equal to a to x is equal to 0. So this is x cube by 3 plus b square x. This is 0 and this is a. So this is 0 minus the minus of a cube upon 3 plus ab square. So this is along BC f dot dr. Okay. Now along CO. So along CO f dot dr. So value is the value of f dot dx. So let us find this along CO. Just find along CO. So along CO we have x is equal to 0 and dx is equal to 0. So x is 0 here and dx is 0. So dx is 0, so this whole expression gets vanished. Now we have x is equal to 0, so this gets also vanished. So this value of this is 0. So we have f dot dr CO is equal to 0. So we have integral f dot dr is equal to OA f dot dr plus AB f dot dr plus BC f dot dr plus CO f dot dr. So f dot dr OA is, value of OA is AQ upon 3. This expression is minus AB square, and this is, value of this is AQ upon 3 minus AB square. ठीक है, and value of this is 0. So now let us add this. So we have AQ upon 3 minus AB square plus AQ upon 3 minus AB square. So this is equal to minus 2AB square. The value of integral f dot dr. Okay, so this is minus 2AB square is the answer. Now let us discuss question number 12. How we can solve this? Find the total work done in moving a particle in a force field given by F is equal to 3xy I cap minus 5z j cap plus 10x k cap along a curve given by x is equal to t square plus 1, y is equal to 2t square, and z is equal to t cube. From t is equal to 1 to t is equal to 2. How we can solve this? So what is the expression for the work done? The expression for the work done is f dot dr along the curve C. Okay, so we have this, we can write as f dot dr upon dt into dt. Okay, so we can change this in the terms of t. Okay, we have, because we have the limits on t as t is equal to 1 to t is equal to 2. So t is equal to 1 to t is equal to 2. So let us convert this. So we have, from here we have the expression as r expression of r is x I cap plus y j cap plus z k cap. Okay, so we have t square plus 1 t square plus 1 I cap plus 2t square j cap plus z t cube k cap. This is r position vector. So dr upon dt is equal to 2t I cap plus 4t j cap plus 3t square k cap dr upon dt. So now we have the value of f as, तो f की वैल्यू क्या हो जाएगी, 3 times of t square plus 1 into y 2t square I cap minus 5 of t cube j cap plus 10 into x t square plus 1 k cap 10x. So we have the value of f dot dr upon dt into dt. So f dot dr is equal to 6t square t square plus 1, 6t square t square plus 1 into dr upon dt, this is 2t, minus 5t cube into, this is 4t, plus 3t square into 10 t square plus 1 into dt. Okay, so this is whole dt, and value of t from, t varies from t is equal to 1 to t is equal to. Okay, on solving this we will get the value as 303 units. This is the total work done. Okay, let us discuss question number 13. How we can solve this? Okay, so find the work done in moving a particle once around a circle C in xy plane. So let us take the xy plane like this. Okay, so we have a circle C. Okay, so the curve is our circle and the radius is 2. This is our radius, and the force field is given by this particular expression. So since this is xy plane, in xy plane we have z is equal to 0. So we have the expression from f as 2x minus y, z, the term of z will get 0. Okay, so I cap plus x plus y j cap plus 3x minus 2y k cap. Okay, so we have the expression for the work done as f dot dr along the curve C. So this we can write as f dot dr upon dt into dt. Okay, if we want to represent this in the terms of t, okay, also in terms of t we can represent the circle as, so we have the expression for circle as x square plus y square is equal to 2 square. So we can represent this as x is equal to 2 cos t and y is equal to 2 sin t. where the t varies from 0 to 2 pi. Okay, so once we move this angle from 0 to 2 pi, it will traverse the whole circle. Okay, so the limit on t is 0 to 2 pi. 0 to 2 pi. This is the limit on t. Okay, so let us place the value here. So we have the position vector r as x I cap plus y j cap. So this we can write as r is equal to 2 cos t 2 cos t I cap plus 2 sin t j cap. Okay, so we have dr upon dt as, we can find the dr upon dt is minus 2 sin t I cap plus 2 cos t j cap. Okay, so now we can um, place the value in this particular expression, and we have the value of f as, let us place x here, x and y here. X is equal to 2 cos t and y as 2 sin t in this particular expression. So we will get the value of f as, let us place this, so 2 cos t and this is 2x, so this is 4 cos t minus, and value of y is 2 sin t, so this is 2 sin t I cap plus x plus y, so this is 2 cos t plus 2 sin t j cap plus, and we have 3x minus 2y, so this is 6 cos t minus 2 times of y, so this is 4 sin t 4 sin to k cap. This is the value of f and this is the value of dr upon dt. So let us take the dot product, f dot dr upon dt. So we have the value of f as, f is equal to 4 cos t minus 2 sin t into dr upon, this is minus 2 sin t, okay, into dt plus this one, this is 2 cos t j cap, so this is 2 cos t plus 2 sin t into 2 cos t into dt, and the limit on t is equal to, limit on t is 0 to 2 pi, 0 to 2 pi. So let us further simplify this. Let us further simplify this. This is minus 8 sin t cos t dt, and this is plus 4 sin square t, and this is plus 4 cos square t plus 4 sin t cos t. Okay, and limit is from 0 to 2 pi. So this is equal to, sorry, this is minus 8 है ना, this will be outside. Okay, so this is minus 8 sin t cos t and this is 4 sin t cos t. This is minus 4 sin t cos t dt plus 4 of sin square t plus cos square t. This is 4 dt. So this we can write as minus 2 sin 2t, minus 2 sin 2t. Okay, so we have this as 4 minus 2 sin 2t into dt. This is 0 to 2 pi, the value of f as. Okay, so this we can write as 4 times of t, limit 2 pi and 0, minus, this is 2 sin 2t dt. So this will be, let us write here, otherwise it will not be visible. So we have f is equal to 4 times of t, 2 pi and 0, minus 2 times of cos 2t upon 2, minus, this is 2 pi and this is 0. So cos 2 pi, this gets cancelled and this will be plus. So we have cos of, this is 4 plus, this is 4 into 2 pi plus cos of 2 pi minus cos of 0. So this is 1 and this is also 1. So this is equal to 8 pi. So 8 pi is the work done. Okay. So value of the expression is given by 8 pi. So the work done is equal to C F dot dr is equal to 8 pi. Answer. Okay. Now let us solve question number 14. How we can solve this? Okay, so we have the value of f as 3x square plus 6y I cap minus 14yz j cap plus 20xz square k cap, and we have to find f dot dr, where c is the straight line joining 0 comma 0 comma 0 to 1 comma 1 comma 1. Okay, so this is the straight line. So how we can write the expression of the straight line? So we have x minus 0 upon 1 minus 0. So this is 1 and this is 0. So 1 minus 0. Similarly, this is y minus 0 upon 1 minus 0 is equal to z minus 0 upon 1 minus 0. So let us take this as t. So we have the value of x as t, y as t, and z as t. Okay. So our expression for f will be, so f is equal to, let us place the value of x, y and z in this particular expression. So this is 3t square plus 6t I cap minus 14 yz is t square j cap plus 20 xz square. So x is t and z square is c. So this is t cube k cap. This is the value of f. Okay, and we have the r vector, position vector, as x I cap plus y j cap plus z k cap. So this we can write as t I cap plus t j cap plus t k cap. Okay. So we have the value of r as this one. Okay. So now we can find the represent f dot dr along c as f dot dr upon dt into dt. Okay. And limit from limit on t will be when x is equal to 0, x is equal to 0, t is equal to 0, है ना? When x is equal to 1, t is equal to 1. So the value of t varies from when when the coordinate is, initial coordinate is x equal to 0, y is equal to 0, z is equal to 0. So when x is equal to 0, y is equal to 0, z is equal to 0, we have this is actually this will be when x y z is 0 0 0. ऐसा लिखो, when x y z is equal to 0 0 0, then t is equal to 0. When x y z is equal to 1 1 and 1, then t is equal to 1. So t varies from 0 to 1, so 0 to 1. So this is, and we have the dr upon dt. So dr upon dt is I cap plus j cap plus k cap. Okay. So we have the value of f as 3t square plus 6t plus minus 14t square plus 20t cube into dt, and it is 0 to 1. ठीक है. Let us further simplify this. So this is 3t square and this is minus 14. So this is 20 t cube, and we have this as 3t square, and this is minus 14. So this we can write as minus 11 t square plus 60, okay, dt, and this is 0 to 1. So this is 20 into t4 upon 4, limit is 0 to 1, minus 16 into t cube upon 3, sorry, this is 11 na, 11 into t cube upon 3, limit is 0 to 1, plus 6 into t square upon 2, limit is 0 and 1. So this is 3t square. This is 20 into 1 by 4, minus 11 into 1 by 3, 3 into 1. Okay, so this is 5 minus 11 upon 3 plus 3. This is 15 minus 11. 15 minus 11 is 4. 4 upon 3 plus 3. This is 13 upon 3 is the answer. Okay, let us discuss question number 15. How we can solve this? So what we have to find? We have to find the line integral f dot dr along the curve C. Okay, from 0 comma 0 to 1 comma 1. Okay, so there are various cases based on these paths. Okay, so we have in the first case the path is y is equal to x square. In the second case the path is straight line from 0 comma 0 to 1 comma 1 and then to 1 comma 1. And in the third case it is straight line joining 0 comma 0 to 1 comma 1. Okay, so in the first case it is parabola, that is y is equal to x square. So y is equal to x square in the first case. Okay, and from 0 comma 0 we have to reach up to 1 comma 1. So along this path we have to find the line integral in the first case. So this is y is equal to x square. So we have the line integral f dot dr as, so we have value of f as y I cap minus x j cap dot dx I cap plus dy j cap. Okay, along the curve C. So C is y is equal to x square. So let us find this. So we have the f dot dr along the curve C is given as y dx minus x dy. Okay, along the curve C. So we have the value of y as x square. So from here we have, let us convert everything in terms of x. So we have dy is equal to 2x dx. So let us place here. So we are converting everything in terms of x. So we have y is equal to x square. So x square dx minus x times of dy is 2x dx. So this is equal to x square dx minus 2x square dx. So this is equal to minus of x square dx, and limit is from 0 to 1. So x varies from 0 to 1. Okay, so this is x is equal to 1. This is x is equal to 1. So x varies from 0 to 1. X varies from 0 to 1. So the value of this is minus 1 by 3. So in the first case it is minus 1 by 3. So let us discuss second case. So in the first case it is minus 1 by 3. So let us discuss second case. So in the second case we have straight line from 0 comma 0 to 1 comma 1. So this is 1 comma 0. So 0 comma 0 to 1 comma 1, and then to 1 comma 1, 1 comma 1. So let us name this path. So we have the path like this. So this is origin. From here we have to reach up to 1 comma 0 and then to 1 comma 1. This is 1 comma 1. So let us name this. This is O, this is A, and this is B. So this is our path. Okay, so we have C. Along the curve C, f dot dr is equal to along OA f dot dr plus along AB f dot dr. Okay, so we have the value of f dot dr as f dot dr is equal to y I cap minus x j cap dot dot product with dr, we can write it dx I cap plus dy j cap. So this is equal to y dx minus x dy. Okay. So along OA we have, this is x axis and this is y axis. So along OA we have y is equal to 0 and dy is equal to 0 and x varies from 0 to 1. And along AB we have x is equal to 1 and dx is equal to 0 and y varies from 0 to 1. So let us place the values here. So we have f dot dr is equal to along OA. So value of f is y dx minus x dy. Okay. So we have f as y I cap minus x j cap. So f dot dr will be take with dot product with dr. So dr we can write as dx I cap plus dy j cap. This is f dot dr actually. F dot dr along C. So this is y dx minus x dy. Okay, along OA plus along AB. Along AB we have y dx minus x dy. Okay, so along OA we have y is equal to 0 and dy is equal to 0. So this is 0 and dy is also 0. So this is also 0. So now we have along AB. Along AB we have x is equal to 1. So dx is equal to 0. So this gets vanished. And we have x is equal to 1 and y varies from 0 to 1. So this is equal to x is equal to 1. So this is minus 1 and dy. And y varies from 0 to 1. So this is equal to minus 1. So in the second case the value is minus 1. Okay, so in the first case it is minus 1 by 3 and the second case it is minus 1. So now let us discuss the third part. Straight line joining 0, 0 to 1, 1. So we have 0, 0 to 1, 1, 1, 1. So what will be the equation of this? So we have the standard equation as y is equal to mx plus c, where c is the intercept. The intercept is 0 here and the slope is 1. So y is equal to, slope is equal to tan alpha. Tan alpha is equal to, this is 1 and this is 1. So 1 upon 1 is equal to 1. Tan alpha is 1. So m is equal to tan alpha is equal to 1. So 1 times of x plus c is 0 here. So y is equal to x is the equation of this line. So along this path we have to find the line integral. So we have c f dot dr is equal to y dx minus x dy along the curve c is equal to y is equal to x. So let us place everything in terms of x. So we have this as y is equal to x, therefore dy is equal to dx. So let us place y is equal to x and dy is equal to dx. So we have x dx minus x times of dx. This is equal to 0. Okay, so value of the third case is 0. So in the first case it is minus 1 by 3, in second case it is minus 1 and in third case it is 0. So let us discuss question number 16, how we can solve this. So we have to evaluate f dot dr along the curve C, where f is given as yz I cap plus zx j cap plus xy k cap. And C is the portion of curve given by, so we have the curve as, the curve is given as, so we have curve as a cos t I cap plus b sin t j cap plus ct k cap. This is the position vector. This we can represent in terms of Cartesian coordinate as x I cap plus y j cap plus z k cap. So from here we have x is equal to cos t, y is equal to b sin t and z is equal to ct. This is not ck, this is ct. This is ct. Okay. So we have f dot dr as f dot dr along the curve C is equal to yz I cap plus zx j cap plus xy k cap dot dx I cap plus dy j cap plus dz k cap. This we can write as along the curve C. This is equal to yz dx plus zx dy plus xy dz, okay, along the curve C. So this we can write as total differentiation of x y z along the curve C, and this is equal to x y z, and the limit is t is equal to 0 to t is equal to pi by 2. Okay, let us further simplify this. Let us further simplify this. So we have the value of f dot dr along the curve C is equal to x y z, limit is t is equal to pi by 2 to t is equal to 0. So let us place the value of x y z. So we have x as, this is our x, this is our x, this is our y, and this is our z. Let us place the values. So we have a cos t, this is b sin t, and this is ct. T is equal to pi by 2 and t is equal to 0. So let us place the value of pi by 2. So cos pi by 2 is 0 minus t is equal to 0. So ct is 0. 0 comma 0 is 0. Okay, 0 minus 0 is 0. So we have, let us discuss question number 17. How we can solve this? So this is basically in the form of m dx plus n dy. Okay, so we know that m dx plus m dy is an exact differential if del n upon del x is equal to del m upon del y. Okay, so this expression, whole expression is in the form of m dx plus m dy. This is m, let us take this as m and this as n. So this is m dx plus n dy. This is in the form of m dx. So this is an exact differential if del n upon del x is equal to del m upon del y. So let us find. So we have the value of m as 2xy cube minus y square cos x. Value of n is 1 minus 2y sin x plus 3x square y square. So we have del n upon del x. Del n upon del x is, so let us differentiate this with respect to x. So this is minus 2y cos x plus 6x y square. Okay, and we have from here del m upon del y. This is equal to 6x y square minus 2y cos x. Okay, so this expression is equal to this expression. So we have del n upon del x is equal to del n upon del y. So hence we can say that m dx plus n dy is an exact differential. Okay, so let phi x comma y is such that d phi is equal to m dx plus n dy. Okay, and total differentiation of phi we can represent as del phi upon del x, partial differentiation of phi with respect to x into dx plus partial differentiation of phi with respect to y into dy is equal to, let us place the value of m and n. So m is 2xy cube minus y square cos x into dx plus n dy. N is 1 minus 2y sin x plus 3x square y square dy. So from here we have del phi upon del x as this expression and del phi upon del y as this expression. So let us further simplify this. Del phi upon del x. So we have del phi upon del x as 2xy cube minus y square cos x and del phi upon del y as 1 minus 2y sin x plus 3x square y square. So from here we have phi is equal to del phi, integration of del phi is equal to phi is equal to, let us integrate this with respect to x. So this will be equal to 2y cube into x square by 2 minus integration of cos x with respect to x. This is y square sin x plus constant of integration. So we are integrating with respect to y. So the constant of integration with is a function of y. Okay. So we have the value of phi as x square y cube minus y square sin x plus f1y. Let us take this as equation 1. Let us integrate this. So from here we have integration of del phi is equal to, let us integrate this with respect to y. So this is equal to y minus 2 sin x y dy. So this is y square by 2 plus 3x square into y square del y. So we have this as y cube upon 3. So this gets cancelled, this gets cancelled. Plus the constant of integration will be a function of x because we are integrating with respect to y. So this is f1x. So we have phi is equal to, let us take this term first. This is x square y cube minus this is y square sin x plus y plus f1x. Okay, this is equation 2. So both are the expressions for phi. So both equations must be same. So both equations are same only if f1y is equal to y, f1y is equal to y, and f1x must be 0. So f1x must be 0. Okay. So now we have the value of phi as phi is equal to f1y is equal to y. So we have we have the expression of phi as this one. Let us place f1y as y. So we have x square y cube x square y cube x square y cube minus y square sin x plus y. This is the expression for phi. So we have the total integration. We have the integration along the curve C m dx plus n dy is equal to integration of total differentiation of phi. Okay, we have the value as d phi. So m dx plus n dy is equal to integration of d phi. Okay, so we have, since m dx plus n dy is an exact differential, so we have taken m dx plus n dy as d phi. So this is integration of d phi. So this is equal to phi, and the limit on phi is from 0, 0 to pi by 2, 1. This is our limit. So let us place the value of phi here. So let us further simplify this. So we have the value of m dx plus n dy as d phi, and integration of d phi is phi. So we have the value of m dx plus n dy is equal to integration of d phi, and this is equal to phi. So let us place the value of phi limits 0, 0 to pi by 2, 1. This is equal to, the value of phi is x square y cube minus y square sin x plus y. Let us place the limits 0, 0 to pi by 2, 1. Let us further simplify this. This is equal to, let us place x as pi by 2 and y as 1. So this is pi by 2 ka whole square into 1 ka whole cube minus 1 square into sin pi by 2 plus 1. Okay, minus 0, 0. So this is 0 minus 0 plus 0. So this is equal to pi square by 4 minus 1 plus 1. This gets cancelled. This is equal to pi square by 4. Answer. Now let us discuss question number 18. So before discussing question number 18, let us revise the concept of circulation. So the circulation K is given as, circulation K along the closed curve is given as f dot dr, line integral along the closed curve. So this is, let us take f as f1 I cap plus f2 j cap plus f3 k cap, and dot product with dr. Dr we can write as dx I cap plus dy j cap plus dz k cap. And this is equal to f1 dx plus f2 dy plus f3 dz. This is the value of circulation K. So let us solve one problem based on the concept of circulation. Let us find this. So if we have to find the circulation along the curve C, where C is the circle. Okay, so we have to find the circulation. The circulation is given by line integral f dot dr along the curve C, and C is x square plus y square is equal to 1. So this is equal to y I cap plus z j cap plus x k cap. Dot product with dr. Dr we can write as dx I cap plus dy j cap plus dz k cap. So this is equal to y dx plus z dy plus x dz. Okay, so this we have to integrate along the C. Curve C is x square plus y square is equal to 1 and z is equal to 0. So z is 0 because the curve is lying in the xy plane. Okay, so this is 0 and this is 0. So this is equal to y dx along the closed curve C. Okay, so the curve is our circle with a radius 1. So any point on this will be cos theta and sin theta because radius is 1 and theta varies from 0 to 2 pi. So we have x as cos theta and y as sin theta because radius is 1. So from here we have the circulation f dot dr along the curve C is equal to y dx along the curve C is equal to the value of y is sin theta and dx is from here dx is equal to minus sin theta d theta minus sin theta d theta and limit on theta is 0 to 2 pi. This is equal to minus sin square theta d theta 0 to 2 pi. So we can write sin square theta as, so we have f dot dr along the curve C is equal to minus of 1 minus cos 2 theta upon 2 d theta 0 to 2 pi. So this we can write as minus 1 by 2 theta limit pi by 2 or 0. Sorry, theta limit is 2 pi na. Theta limit is 2 pi or 0 minus sin 2 theta upon 2 pi or 0. Okay, so this is equal to sin 2 theta upon pi. Let us further simplify this. So line integral f dot dr, that is circulation along the curve C is equal to minus 1 by 2 theta limit is 2 pi or 0 minus integration of cos 2 theta, this is sin 2 theta upon 2, limit is 2 pi or 0. So this is 2 pi. So sine of 4 pi is 0 and sine of 0 is 0. So this whole term gets vanished and this is equal to minus 1 by 2 into 2 pi. So this is equal to minus pi. So the circulation is minus pi. Let us discuss question number 19, how we can solve this. So we have to find the integral I along the curve C t dot dr, where t is the unit tangent vector. Unit tangent vector. Okay, so unit tangent vector. So we have already studied the tangent, unit tangent vector we can represent as dr upon ds. Here the curve C is a unit circle. Okay, so the radius of this will be 1 unit. So this we can write as x square plus y square is equal to 1. Okay, so let us further simplify this. So we can write this integral as t dot dr upon ds into ds, okay, along the curve C, and dr upon ds is unit tangent vector. This is t is unit tangent vector. So I is equal to along the curve C t dot into ds, and this is unit tangent vector. So t dot product of unit tangent vector is 1. So I is equal to 1 into ds, and s is the length of curve. Okay. So on integrating it throughout the circle, we will get this as the perimeter. So since the radius is 1, so the perimeter will be 2 pi into r. So r is 1. So this is equal to 2 pi. So the value of integral is 2 pi. Okay. So we have this as along the curve C t dot dr is equal to 2 pi. Okay. Now let us discuss question number 20. How we can solve this. So we have the value of f as f is equal to 3x square plus 6y I cap minus 14yz j cap plus 20xz square. Okay, so we have to find the f dot dr. Okay, so f dot dr will be is equal to 3x square plus 6y into dx minus 14yz dy plus 20xz square dz. This is the value of integral along the curve C. Have the equation, parametric equation as x is equal to t, y is equal to t square and z is equal to t cube. So from here we have dx is equal to dt, dy is equal to 2t dt and dz is equal to 3t square dt. Okay, so let us put this in this particular equation. So we have this as f dot dr is equal to along the curve C. So this is 3t square minus plus 6t square into dx is dt minus 14 into value of y is t square into z is t cube into dy is 2t dt. Okay, plus 20 into xz square, 20 into t into z square is t to the power 6 into dz is 3t square dt. Okay, so now let us further simplify this. The f dot dr is equal to along the curve C. This is 90 square minus 28. This is 90 square minus 28 into t to the power 6 dt plus this is 60. This is t to the power 9 dt. Okay, dt. Let us further simplify this, and value of t will be from, since we have x varies from 0 to 1. Okay, because the coordinate varies from 0 comma 0 comma 0 to 1 comma 1 comma 1. Okay, so x varies from 0 to 1 and x we have taken as t, so t varies from 0 to 1. So the integral will be from t varies from 0 to 1, 0 to 1. So let us further simplify this. Now the value of integral f dot dr along the curve C is equal to 0 to 1. This is 90 square dt. So this will be, sorry, let us put the limit also. This is 9 times of, this is t square dt, this is t cube by 3, 1 comma 0 minus 28 into t 7 upon 7, limit is 0 to 1, plus 60 into, this is t to the power 10 upon 10, limit is 0 to 1. Let us place the limits. So the value of integral is f dot dr along the curve C is equal to 9 upon 3 minus 28 upon 7 plus 60 upon 10. So this is equal to 3 minus 4 plus this is 6. So this is 9 minus 4 is equal to 5. Okay, so the value of integral is 5. So let us discuss question number 21, how we can solve this. So we have the integrate the function f is equal to x square I cap minus xy j cap from 0 comma 0 to 1 comma 1 along the parabola y square is equal to x. So the value of integral is f dot dr along the curve C. So this is x square dx minus xy dy. Okay, so we have the value of parabola as y square is equal to x. So this is 2y dy is equal to dx. So we have this as 2y dy is equal to dx. So we have this as x square dx minus x into y dy is dx upon 2. Okay, so the value of this is from 0 to 1, the integral. So we have this as x cube upon 3, limit is 0 to 1 minus 1 by 2 x square upon 2, limit is 0 to 1. So this is equal to 1 by 3 minus 1 by 2 into 1 by 2. This is equal to 1 by 3 minus 1 by 4. This is 1 upon 12 is the answer. Let us discuss question number 22. How we can solve this? So we have to evaluate the integral f dot dr along the curve C. So this is equal to x square y square I cap plus y j cap dot dx I cap plus dy j cap. So the value of integral is along the curve C, the x square y square dx plus y dy. Okay, and we have the curve as y square is equal to 4x. So from here we have 2y into dy is equal to 4 dx. So from here y dy is equal to 2 dx. So this is I is equal to x square into value of y square is 4x. So we have x square into 4x dx plus y dy is 2 dx. Okay, and the limit is from x varies from 0 to 4. 0 to 4. So this is equal to 4 into x cube dx. X cube dx limit is 0 to 4 plus this is 2 times of dx. This is 0 to 4. So this is equal to 4 into 4 cube upon 3. Sorry, x4 upon 4, no? This will be 4 to the power 4 upon 4. This gets cancelled plus 2 times of 4. So we have this as I is equal to 4 to the power 4 plus 2 times of 4. So let us calculate this. So we have this as, let us use the calculator, 4 to the power 4 plus 8. This is 264. So we have the value of I as 264. Let us discuss question number 23. How we can solve this? So we have the integrals f dot dr. Okay, I is equal to, and we have the value of f as So let us directly write down this f dot dr we have to find now. So we can write this integral as f dot dr upon dt into dt. Okay, let us convert everything in terms of t. Okay, after that we will integrate this from t is equal to pi by 4 to pi by 2. Okay, so we have this as, let us find the value of dr upon dt. So we have the r vector as r is a cos t I cap plus a sin t j cap plus bt k cap. From here we have dr upon dt as minus a sin t I cap plus a cos t j cap plus b k cap. Okay, so we have the value of I as, so c times of this is 3a square sin cube t cos t. Okay, plus this is a cos t, and this is a times of 2 sin t minus 3 sin t cube. So this will be plus a square 2 sin t minus 3 sin cube t into cos t plus b square sin 2t. F dot dr upon, this is dr upon dt, and this is value of f. Okay, into dt, and the value of limit is from pi by 4 to pi by 2. Okay, how we will solve this? Let us take sin t is equal to t, then take sin t is equal to p, then cos t dt is equal to dp. Okay, so use this substitution, you will get the answer. So you will get the answer as c upon t a square plus b square. This is simple integration. Use this substitution to get the result. Okay, let us discuss question number 24. How we can solve this? So we have the value of f as, we have to find the integral f dot dr along the curve C. Okay, an arc of the curve is given as r is equal to cos t I cap plus sin t j cap plus t k cap. Okay, let us compare this with the position vector in Cartesian coordinate. Okay, so let us take this as x I cap plus y j cap plus z k cap. So we have the value of x as x is equal to cos t, y is equal to sin t, and z is equal to t. Okay, let us find, we can write this integral as I is equal to, along the curve C, f dot dr upon dt into dt. Okay, so we have the value of f as f is equal to z I cap plus x j cap plus y k cap. So let us substitute, z is equal to t, so this is t I cap plus x is cos t j cap plus sin t k cap. Okay, so f dot dr upon dt, this is the value of r. So we have dr upon dt as, this is minus sin t I cap plus cos t j cap plus k cap. Let us take the dot product. So we have the value of I as f dot dr upon dt. This is minus t sin t plus cos square t, and this is plus sin t, f dot dr upon dt. Na? This is r. So this is dr upon dt and this is f. So this is sin t. This is the value of dr upon dt into dt, and value of t varies from 0 to 2 pi. Okay. So let us integrate this with parts, by parts. Let us further simplify this. This is simple integration. I will show you the integration of t sin t. So we have the value of t sin t, integral t sin t dt from 0 to 2 pi. So this is equal to t times of integration of sin t is minus cos t, minus, so limit is from 2 pi and limit is from 0 to 2 pi, minus integral 0 to 2 pi d by dt of t. So this is 1 times of integral of sin t is minus cos t, so minus minus plus, this is cos t into dt. This is equal to minus of t cos t, limit is 0 to 2 pi, plus, and cos t, integration of cos t is sin t, limit is 0 to 2 pi. So this will be 0, straight away 0. So this is equal to minus of t. Well, let us put the value of t. So this is 2 pi into cos 2 pi is 1 and minus 0. This is minus 2 pi. So the value of minus t sin t is t sin t. The integral of t sin t is minus 2 pi. So minus of t sin t will be 2 pi. So I is equal to 2 pi times of plus. This is cos square t. This we can write as 1 plus cos 2t upon 2 dt. This is 0 to 2 pi, plus integral cos sin t. Sin t is minus cos t. Minus cos t, limit 0 to 2 pi. Okay. Let us further simplify this. So we have the value of I as 2 pi. 2 pi plus, this is half times of 2 pi, plus integral of cos 2t, this is sin 2t upon 2, integral is 2 pi or 0, plus this is minus we can take out, cos 2 pi is 1 and cos 0 is 1, this is 0. So this is equal to, I is equal to 2 pi plus pi, and this is equal to 3 pi. 3 pi is the answer. Let us discuss question number 25, how we can solve this. So we have to evaluate the integral I along the curve C, f dot dr, where f is equal to xy I cap plus x square plus y square j cap. Okay, so we have the value of f dot dr as, this is xy into dx plus x square plus y square into dy. Okay, so let us plot this. So we have the curve C is the x-axis. Okay, x-axis from x is equal to 2 to x is equal to 4. So this is x is equal to 2 and this is x is equal to 4. x is equal to 2 to x is equal to 4, and the line x is equal to 4 from y is equal to 0 y to y is equal to 12. So this is the line of x is equal to 4, and this is from y is equal to 0 to y is equal to 12. This is y is equal to 12. So this is y is equal to 0, and this is y is equal to 12. So coordinate of this will be, so this is x is equal to 2. So this is 2 comma 0. 2 x is equal to 4. So this is 4 comma 0. Let us name this a, b, and this is c. And this is 4 comma 0, and this is 4 comma 12. So y is equal to 0 is this line, and y is equal to 12 is this line. So along the curve a, b, and c, so we have to evaluate the integral. Okay, so this we can break as f dot dr along the curve c is equal to along ab plus along bc xy dx plus x square plus y square into dy. So along AB we have y is equal to 0 and dy is equal to 0. So along AB we have the y is equal to 0. So this term will gets vanished, and we have the value of dy as 0. So this will also gets vanished. Okay, so we are left with integral along the curve BC. So we have f dot dr along curve C is equal to along BC. Along BC we have, and along BC we have x is equal to 4. So dx is equal to 0. Okay, so this xy dx gets vanished. So we are left with x square plus y square into dy. So we have x is 4. So this will be equal to 4 square plus y square. 4 square plus y square into dy. Okay, so integral on y will be limit on y. So limit on y will be y is equal to 0 to y is equal to 12. So this is 16y plus y cube upon 3, and limit is 0 to 12. So this is equal to 16 into 12 plus 12 cube upon 3. So its value is 16 into 12. Let us use the calculator. 16 into 12 plus 12 cube upon 3. So value is 768. 768 is the answer. Now let us discuss question number 26. How we can solve this? Find the work done in moving a particle in a force field along the line joining 0, 0, 0, 2, 2, 1, 3. Okay, so we have the equation of line as x minus 0 upon 2 minus 0 is equal to y minus 0 upon 1 minus 0 is equal to z minus 0 upon 3 minus 0. Let us take this as t. So we have x upon 2 is equal to y upon 1 is equal to z upon 3 as t. So from here we have x is equal to 2t, y is equal to t, and z is equal to 3t. Okay, this is the equation of this line in parametric form. Equation of line in parametric form. Okay, so let us find the work done. The work done is equal to f dot dr along the curve C. So this we can write as 3x square I cap plus 2xz minus y j cap plus z k cap dot product with dx I cap plus dy j cap plus dz k cap along the curve C. So we have work done is equal to 3x square dx plus 2xz minus y dy plus z dz along the curve C. Okay, so from here we have dx is equal to 2 dt, dy is equal to dt, and dz is equal to 3 dt. Let us place the value. So w is equal to 3x square dx plus 2xz, 2 into x is 2t into z is 3t minus y is t. into dy is dt plus value of z is 3t and dz is 3 dt. Okay, and integral is from, since x varies from here, x varies from 0 to 2, and we have taken the value of, sorry, y varies, y is equal to 2 and y varies from 0 to 1. Okay, here let us repeat this. So we have y varies from 0 to 1 and we have taken y as t, so t varies from 0 to 1. Okay, as simple as that. So let us further simplify this. So we have worked on as 3 into 3x square dx 0 to 1 plus, sorry, the value of x is 2t, na, we have not written here. 3 into 2t whole square into value of dx is 2 dt and t varies from 0 to 1. So this is equal to, this is 6 into 4t square. This is 4t square and this is 6, 24t square dt plus this is 4 3 is 12, 12t square minus t dt plus 9t dt. Okay. So this we can write as, this is 24t square, this is 12, this is 36t square dt plus 8t dt, and this is 0 to 1 and this is limit is 0 to 1. This is work done. So work done is equal to 36 into t cube by 3, so this is 1 by 3 plus 8 into t square upon 2, this is 1 by 2. So this is 12 3 36 and this is 4. This is 12 plus 4 is equal to 16 is the answer. So now let us discuss question number 27, how we can solve this. So we have find the circulation of f round the curve C, where f is given as f is equal to I e to the power x sin y plus j e to the power x cos y. Okay, and C is the rectangle whose vertices are 0, 0, 1, 0, and we have this as 1, pi by 2. Let us take this as 1, pi by 2 and this as 0, pi by 2. Okay, so this is our circle, sorry, this is our rectangle. Okay, so let us name this as A, B, C and D. Okay, so along AB, this is AB, so this is our rectangle. So along AB we have y is equal to 0 and dy is equal to 0. Along BC we have x is equal to 1, dx is equal to 0. Along DC we have y is equal to 0 and dy is equal to 0. Along AD we have x is equal to 0 and dx is equal to 0. So let us calculate one by one. So we have the integral f dot dr along the curve C is equal to integral along AB f dot dr plus along BC f dot dr plus along CD f dot dr plus along DA f dot dr. So along AB, let us calculate along AB, f dot dr is equal to e to the power x sin y dx plus e to the power x cos y dy. Okay. So along AB we have y is equal to 0 and dy is equal to 0. So dy is equal to 0, so this gets vanished, and we have y is equal to 0. So y is equal to 0, then sin y is equal to 0. So this is equal to 0. So from here we have integral f dot dr along AB is equal to 0. So now let us find along BC. So along BC. So along BC we have dx is equal to 0. So dx equal to 0, then this gets vanished. Dx is equal to 0. So e to the power x sin y dx gets vanished. So and we have x varies from x is equal to 1 and y varies from 0 to pi by 2. So this is, so we have this along BC, we have the limit on y is 0 to pi by 2, and this is x is equal to 1. So e to the power 1 into cos y dy. So this is equal to e into integral of cos y. Cos y is sin y, and limit is 0 to pi by 2. So this is equal to e to the power sin pi by 2 is 1 and sin 0 is 0 minus 0. This is equal to e. So here integral BC f dot dr is equal to e. Okay. Now let us find along CD. Let us find along CD. So along CD we have y is equal to 0 and dy is equal to 0. So we have dy is equal to 0. So this e to the power x cos y dy gets vanished, and y is equal to 0. Sorry, y is equal to pi by 2, no? Y is equal to pi by 2. Y is equal to pi by 2 and dy, because y is constant, so change in y is 0. So y is equal to pi by 2, and x varies from 1 to 0. So the limit on x is 1 to 0 e to the power x into sin pi by 2. Sin of y is equal to pi by 2, as it is y is equal to pi by 2 is constant. Sin pi by 2 is 1 into dx. So the integration of e to the power x dx. So e to the power x is ex, and we have limit as 1 to 0. So this is e to the power 0, matlab 1 minus e. So here we have integral along CD f dot dr is equal to 1 minus e. Now let us find along the dA. Let us find it along dA. Along dA. So along dA we have the value of x is 0. So e to the power 0 is 1 into sin y into dx. Since x is equal to 0 and dx is equal to 0, so this term gets vanished because dx is 0 and we have x as 0. So e to the power x will be 1 because e to the power 0 is 1. So e to the power 0 into cos y dy, and limit on y is from pi by 2 to 0, pi by 2 to 0. So this is equal to e to the power 0 is 1 and cos y is sin y, and this is limit is pi by 2 to 0. So this is equal to 1 times of sin 0 is 0, 0 minus sin pi by 2 is 1. So this is equal to minus 1. Okay. So now let us add this. So along this we have integral along dA f dot dr is equal to minus 1. So now let us add all this. So value along AB. So AB is 0. The value of this is 0. Along BC we have this as E. Okay. Along CD it is 1 minus E. And along DA we have this is minus 1. So let us add this 0 plus E plus 1 minus E minus 1. So E gets cancelled, 1 and minus 1 gets cancelled. This is 0. So the value of f dot dr along the curve C is 0. Let us discuss question number 28. How we can solve this? So we have a vector field is given as f is equal to sin y I cap plus x times of 1 plus cos y j cap. Evaluate the line integral over the curved circular path x square plus y square is equal to a square. Okay. So this is our circular path. This is x square plus y square is equal to a square. So we have this as f dot dr along the curve C is sin y dx plus x1 plus cos y dy along the curve C. So this we can write as sin y dx plus x cos y dy plus x dy along the curve C. So this we can write as differential of x sin y, okay, plus x times of dy. Okay, so in the parametric form we can write this as, represent the circle as x is equal to a cos t and y is equal to a sin t. Okay, and x times of dy. So we have value of x as a cos t into dy is a times of cos t. So dy will be a cos t dt. Cos t dt. And let us place the value here. So we have d as, this is integral along curve C. So we have the value of x as x is a cos t into sine of y is a sin t plus this is a square cos square t dt. Let us further simplify this. So we have the value of I as, so differential. So this we can represent as integral of differential. So this is a times of cos t sine of a sin t. Limit is from, the t varies from, here t is the angle and t varies from 0 to 2 pi. So this is 0 and this is 2 pi plus this is a square. This we can write as 1 plus cos 2t upon 2 and this is dt. And integral is from 0 to 2 pi. Okay. Let us put the values of limits. So we have this value as I is equal to, this is cos 2 pi and cos 2 pi is 1 and this is sine of a sine 2 pi. So sine 2 pi is 0 and sine of 0 is 0. So this is 0. 0 minus and cos 0 is, let us place the limit as 0. So cos 0 is 1 and sine of a of sine t. So a sine t, this will be 0 because t is 0 and sine 0 is 0 plus a square upon 2. Let us take this out and t limit from 0 to 2 pi plus integral of cos 2t is sine 2t upon 2 and limit is 0 and 2 pi. So sine of 4 pi, 4 pi is 0 and sine of 0 is 0. So I is equal to a square by 2 into 2 pi. So this is pi a square is the answer. Let us discuss question number 29. How we can solve this? Find the work done in moving a particle in a force field given by F is equal to 3x square I cap plus 2xz minus y j cap plus zk cap and the straight line. So straight line is from 0 comma 0 to 2 comma 1 comma 3. So the equation of a straight line will be x minus 0 upon 2 minus 0 is equal to y minus 0 upon 1 minus 0 is equal to z minus 0 upon 3 minus 0. Let us take this as t. So we have x is equal to tt, y is equal to t and z is equal to 3t. Okay. So let us write down the integral. F dot dr along C is equal to 3x square dx plus 2xz minus y dy plus z dz along curve C. So this, let us place the value here. So here we have dx is equal to 2 dt, dy is equal to dt, and dz is equal to 3 dt. So here we have 3 times of x square. X square is 40 square into dx is 2 dt plus 2 times of xz, x and z. So this is 60 square. 2 into 2t into z is 3t minus y is t and dy is dt plus value of z is 3t into dz is 3 dt, and the limit on t will be um, since x varies from here we have taken here y varies from 0 to 1, y varies from 0 to 1, so y we have taken as t, so t varies from 0 to 1. Okay, so on finding on if integrating this, you will get the answer as 16. Okay, similarly for b, in b how to proceed for second part. So we have the curve defined as x square is equal to 4y, 3x cube is equal to 8z, and x is sorry okay, so let us take x is equal to t. Okay, so from here y is equal to x square upon 4, so this will be equal to y is equal to x is t, so this is t square upon 4, and from here we have z is equal to 3x cube upon 8, so this is 3t cube upon 8. So in parametric form, x, y and z, we have this as x as t, y as t square upon 4, and z as 3t cube upon 8. So we have the value of integral f dot dr along C is equal to 3x square dx plus 2xz minus y dy plus z into dz. Okay, so from here we have dx is equal to dt, dy is equal to 2t dt upon 4, and dz is equal to 3 into 3t square dt upon 8. Okay, so di is equal to t dt upon 2, and dz is equal to 9t square dt upon 8. Okay, let us place the value here. So 3 times of the value of x is t and dx is dt, plus 2 into xz, the value of x is t into z is 3t cube upon 8 minus value of y is t square upon 4 into dy is t dt upon 2 plus z dz, 3t cube upon 8 into dz is 9t square dt upon 8. Okay, x varies from 0 to 2, so t also varies from 0 to 2. Okay, on integrating this we will get the answer. Let us discuss question number 30. Okay, so this is the last question, so we have reached up to question number 30. So compute the line integral along the curve C y square dx minus x square dy about the triangle whose vertices are. So the vertices of triangle are 1, 0, 1, 0. This is 0, 1, 0, 1 and minus 1, 0. Okay, so this is our triangle. Okay, so let us name this as A, B and C. Sorry, we can name this as like this. We will move in anti-clockwise direction. So this is A, this is B and this is C. We will move in this manner. Okay. So let us take this as, we can break this integral as along AB plus along BC plus along AC. Okay, so equation of this, the coordinate is 1, 0, this is 0, 1, this is minus 1. The equation of this will be y is equal to minus x plus 1. This is y is equal to 0, and equation of this is y is equal to, this is y is equal to x plus 1. Okay, so let us find one by one. So along AB, f dot dr is equal to y square dx minus x square dy. So along AB we have y is equal to 0 and dy is equal to 0. So y is 0 and dy is equal to 0. So y square dx will get vanished and x square dy will get vanished. So value of AB f dot dr is 0. Let us find along BC. So along BC f dot dr is equal to along BC y square dx minus x square dy. Okay. So along BC we have x is y is equal to minus x plus 1. So dy is equal to minus dx and y is equal to, so this is along BC y is equal to minus x plus 1. So this is 1 minus x dx. Okay. Minus, and we have dy is equal to minus dx. So dy minus dx. So this will be plus. So x square into dx, and limit is from this is minus 1. This is 1 and this is 0. So limit is 1 to 0. So this is 1 minus 2x plus x square dx plus x square dx. This is 1 to 0. This is 1 to 0. So this is x minus, this is x square plus x cube by 3. Limit is 1 0, and this is plus x cube by 3. Limit is 1 and 1 to 0. So this is, let us put the integral here, put the limits here. So this is 0 minus 1 minus 1 plus 1 by 3 plus this is 0 minus 1 by 3. So this gets cancelled and this is minus 1 by 3 minus 1 by 3. This is minus 2 by 3. Okay. So along BC we have, so along BC f dot dr is minus 2 by 3. Let us find along CA. So along CA f dot dr is equal to y square dx minus x square along CA. So along CA we have the equation as y is equal to x plus 1. So from here we have dy is equal to dx. So we have this as, let us place the value of y as x plus 1. X plus 1 whole square into dx minus x square into dy is dx. And limit on x is 0 to minus 1. 0 to minus 1. So this is x square plus 2x plus 1 into dx minus, this is 0 to minus 1. This is x square dx 0 to minus 1. This is x cube by 3 plus x square plus x. Limit is 0 to minus 1 minus x cube by 3. Limit is 0 to minus 1. Let us further simplify this. F dot dr along CA. So along CA f dot dr is equal to, let us place the limit. So this is minus 1 by 3 plus 1 minus 1 minus 0 minus this is minus 1 by 3 minus 0. So this is minus 1 by 3, this gets cancelled, plus 1 by 3, this is 0. So along CA f dot dr is equal to 0, and then along AB f dot dr is 0. This we have already found. So now let us sum this. So along AB, we have the value as 0. Along BC the value is minus 2 by 3, and along AC it is 0. So we have along the curve C, y square dx minus x square dy is equal to 0 minus 2 by 3 plus 0. So this is minus 2 by 3. Okay. So this is all about top 30 questions on the topic of line integral. Okay. Thank you.